Hello, everybody. My name is Damon Feldman. I've been with MarkLogic for a long time, delivering some of our larger projects and also working on our internal patterns and product direction. And I am here to talk to you about architecture, how to put the structures in the architecture inside of a data hub, and also how to situate the data hub within the larger enterprise. So let's get started. Here's some of the things I'm going to cover. There's going to be a quick demo first, because this particular architecture discussion is also tied to an example app. We call it the Research Hub framework. And that sample app is a leave behind for you to go download and play with after the talk, or to trace a particular concept or bit of code or configuration and see how that really works. So I'll show that first and kind of give some context. And then I'll talk about where the data hub fits in the enterprise, and then dig in and spend most of our time on the internals of the data hub, architecturally, how to organize things, what kind of patterns to use, how to model the data, some small things like tips and tricks that just don't seem to fit anywhere else but are useful to know, and how to expose things with data services. And a little bit about how to do this within Data Hub service. And all this within the context of this example app that I'll show now. So let me switch. So this was part of the earlier keynote information. So you may have seen this right after Gary's talk. We showed this. This is fundamentally a search and discovery application. There's 5 or 6 different kinds of data. So we've integrated a lot of data. That's the essence of the data hub. It's for integrating data, exposing it, organizing it, what we call curating it. And we'll talk about that through the talk. There's some textual data, publications. Let's look at those now. So if I'm interested in probiotics, I can look at the publications about probiotics. And here are a number of records. These records in MarkLogic are entities. So a document, like a publication or an article or a tech report or a lab notebook or what have you, is an entity. I can also look for structured records. Here are genes related to insulin. So this is more of a structured record. It's not full of text. I'm not doing a text search. I'm doing more of a lookup. All the types of data have various criteria that we can drill down and slice and dice, as well as when we look at publications, we can see more clearly that this is really an analytical view, giving really more of a sense of how many journals have been brought in over what year that are related to insulin, who the main authors are. Apparently, some of these people are real heavy hitter experts on insulin, how heavily cited, and so on. So this is structured and unstructured data. And then here we have a little bit of transactional data. So I can go and I can look at any of these workspaces, as they're called, and I can update them. I can give them a new description. I can log in to see the details of those. And where were we? Workspaces. And I can also modify them. I say, oh, you know, I read this, it turned out not to be relevant. I'm going to take that out with a little trash can. So I have both a reporting and discovery aspect and also a collaboration and transactional update. Right? That's important for MarkLogic. It's a transactional update system that is also a big data discovery system. One of the big items to emphasize here, and we'll talk about the architecture of this and how to think about this, is that it is a structured query system, but also a semantic system. If I go to the graph link, I'm going to see the semantic linkages among the publications and the concepts and items described or discussed within those publications. Here's a publication, probiotic engineering. Here are 3 genes that are discussed in there, a couple authors who wrote it, a protein that's being discussed in there, and so on and so forth. The last thing I'll show in this quick demo is I can do a little bit of very lightweight AI where I just analyze this graph. MarkLogic has a lot of AI capabilities. This is super simple. We're really just doing some SPARQL query, right? Some RDF standard query to get the right triples and count them and analyze them, and then using the relevance algorithms that have been built into MarkLogic. So now I have all these other papers that are relevant, right? So here is a paper that discusses these flaxseed variants, and here is a paper with a lot of lines attached to it that's discussing 4 of the genes that are relevant. So if I'm interested in what genes are involved in probiotics, I would read that paper. Okay, so we're not going to cover that anymore. That's just to orient us a little bit. That application is built on a framework called the Research Hub Framework. You can go and download and use that. The reason I mention that is that the little bits of configuration and code that I show later will be from that project, and the data flows and steps in the Data Hub are from that project. So that's something to go back and refer to later if you have any questions about what I'm talking about today. So first, let's talk about how data hubs fit into the enterprise architecture, right? The big picture, not everything is a data hub. In MarkLogic, we tend to think that it is, but it's very important for us to also guide people and consider how the data hub fits into the architecture. So here's a typical architecture. People have data silos. People have different bits of data. So source system 1, 2, 3. Some systems, some companies have 2,000. One large customer I was talking to had 2,000 different databases. And that's the reality people deal with. And what we usually do is we do a little ETL, we pull that data out, we put it in the data warehouse, and that at least gives us some data integration. You can now go to the data warehouse and get a consolidated view of some sort. The issues start to come in when more kinds of analysis and the best source for the best course starts to come into play. Well, you need to do some searching. Data warehouses don't really search, so you need a search engine. And then traditional relational technologies don't handle graphs well. So maybe you want a graph database, triple store, or a graph database, both similar. Geospatial data sometimes is available, sometimes not. You start to have this proliferation of 1Z, 2Z tools, and all that means more data copies, more data movement, processes analogous to ETL. And what about binaries and the raw incoming data? You can lose that, and you don't have time to build a whole new model for the data warehouse. You just throw it in the data lake. So you get a lot of data all of a sudden. And that works to an extent. You can do reporting on a data warehouse or a data lake. You can do business intelligence on a data warehouse. Data warehouses are absolutely perfect for business intelligence and dimensional analysis. They're great. But for real-time and live access and really making the business function, right? Because these two, BI and reporting, those are what we call observe the business functions. You can look at what's happening in the business, and that's great. How many customers in this zip code? But when you want to really run the business, when you want to monitor possibly fraudulent transactions in real time, you want to expose a portal for your customers to see and interact with your various systems in real time, you need something else. And at one time, an ESB or some kind of orchestration was the way to go. We've moved forward to using microservices a little more now. These are all ways to coordinate all these different data sources, including sometimes the source systems. And on top of these services, you can build an app. Here's a mobile app through an API gateway, and here's some web apps. May or may not use an API gateway. So this is the world of a typical architecture, and this is fine, but it is complicated and difficult to maintain. So to simplify some of this, in this general area, there's things to do to layer a hub on top of this and start to move some of the functionality, or even sometimes replace entire systems with a data hub. Store the data, provide APIs, have the raw data lake function, and also do some mastering, which is another box that isn't even on this diagram. So let's look at how you might look at some of this complexity and put in a hub. So if a hub was put in place, it doesn't have to replace every box in the enterprise, right? It's just a place to simplify some things. And here we have a diagram where the various source systems go into the data hub. That's the place where the data is going to be made high quality. Okay, deduplicate the data, put some data cleansing rules on the data, check the formats of the data, and expose the data. So once that data is there and exposed and secured and handled in a better governed way, where you really know what's going on, it's natural to redirect microservices and APIs, and even the somewhat legacy orchestration bus, to the data hub. And instead of putting things directly into the data warehouse, it's good to put the data hub information into the data warehouse. Reason being, it's helpful not to have different systems with different data. So if you've cleaned it up one way in the data hub with certain rules and validated it one way in terms of what's acceptable and not acceptable data, if you put different data in the data warehouse with a different ETL process, you're going to have inconsistent results from different systems. So it's nice to have the data hub as the cleanest, most heavily invested data, and then you can send that out to other places. So today, we're going to talk about that example. That example is just a web app. There's a little middle tier, very lightweight, really a pass-through, Node.js middle tier. It's fundamentally a web app sending REST services to a MarkLogic data hub, running in DHS in the cloud. And that's one small illustration of all the other things that you might want to do. It does not show bulk export to a downstream system like a data warehouse. It does not show an export to a data science machine learning environment. It does not show all the other kinds of things that you would do with a data hub, BI and reporting. It does not show how to do your reporting off your data hub. But this one slice is at least illustrative. I just don't want to give the impression that MarkLogic is in the business of building web apps. We're not. We're in the business of re-architecting and reforming the core data movements of the enterprise to make them more standard and better governed. So diving now inside the data hub, you may have seen this diagram. We use this diagram a lot. We have the various source systems. They go into the data hub through ingestion, and then we store them as is. That's important. That's lineage and traceability. By having the data stored in its original format with its original values and its original field names, you can see in the data hub an exact reflection of what's going on in the source system. And if there's any kind of a problem, you can trace it back. If you want to know how you got a certain number or a certain value, you can trace it back. So the as-is data enables that traceability. It also makes reprocessing much easier because it's all there. And then we turn it into curated data in a lot of ways, principally by mapping into a common structure. Doesn't have to be fully common, but at least some of it should be common. Mastering and deduplicating it. And then we expose it with data services. You can query it, you can search it, meaning structured query versus textual search, export it to other systems, run reporting directly on it. So that's really nice, right? You don't have two systems, analytical system and a warehouse and then MarkLogic, you can have one. And again, our sample app, it's actually going through these query and search endpoints. Our sample app is just showing direct transactional access to the data hub. Now, one of the key architectural things to think about, and this confuses all users of MarkLogic and confused me for a long time, is actually a partner at RandomBit who said this. Think about the data gravity. So what do you put in the data hub? And the question is, well, what's related to data? Because the data hub does a lot of processing. It's not like a relational database where all you can do is hit it with SQL. You build data services into the hub and data transforms. So here's a little, this is taken from the earlier example, just things have moved around a little. We have a data hub, a data lake, a data warehouse, orchestration bus, and a microservice. They're all interacting. Well, what do you want to code into your microservice, and what do you want to build as a service within your data hub, right? And then there's also ETL pipelines and ingest pipelines. What do you want to do where? So here's some of the data gravity questions. Does this require a lot of joining, filtering? Do you need transactional updates, right? If this fails in the middle, are you in trouble? If you are, you might want to put it in the data hub, which has transactional guarantees. Is it a combination of the many different data models? I'll talk about multi-model in MarkLogic a lot. Does it have some text query and some structured query? Right, that example, we were looking for publications on probiotics. We had the keyword probiotic, but then we also had lists of dates and topics. So it's a structured and unstructured query being combined together. You don't want to try to code that up in Python. You really want to do it in the product that does that. Is it around validating, transforming, and mastering data? Especially transforming, right? Use the mapping capabilities in the data hub to put things into the right way and to track the history and lineaging and to govern those transforms so you know what you've done. Does it search, and is it fuzzy? So that recommendation algorithm was fuzzy. Even the relevance-based search for the word probiotic is fuzzy. And certainly if you're using mastered data, we have fuzzy searches that make that a good place to do that. So it's really a question, we can call it data gravity, we can call it data logic as distinct from business logic. If it's about the business rules of who's allowed to return an order after 7 days and other things that are not really related to data, then they don't really belong in the data hub. But if they're related to data, they do. So that's the first thing. Let's talk about data modeling. I mentioned multi-model. Well, let's start with this. This is essentially a conceptual model, but for MarkLogic, the conceptual model really is the data model in large measure. There's a few differences, but we don't need to put a lot of strange relations like a relational database would, where there's a many table between people and addresses or something. We just have the basic entities. So in that example that we're talking about today, we have publications. Those publications mention things like drugs and proteins and genes. They are authored by a group of authors. And proteins and genes have a relationship because a gene is the encoding to synthesize a protein, right? One codes for the other. And of course, drugs have active ingredients. So there's these relationships. These are the actual business relationships. That's why it's like a conceptual model. We're modeling the conceptual relationships. We're not modeling a lot of physical lint that we don't want to deal with. So those are entities. And these first two formats that MarkLogic handles, JSON and XML, are the two representations for an entity. And that's our primary model. We're a document-oriented system at core, but less and less focused on that, because what we now have is SQL and RDF data sets as well. Usually, it depends on your use case. Usually the SQL and RDF are projections out of the documents, data lenses. We'll talk about that later. Sometimes you pull in RDF directly, and of course you can take relational data and convert it. And while these aren't exactly different formats, the fact that there are native functions and indexing and so on for text, geospatial, and binary data is also important. And this really drives a lot of this talk. If all the data was relational data, I wouldn't need to create this talk about how to do architecture differently. It's the combination of all these models together. It's the combination of the models together that makes the architecture different. And instead of having 4 or 5 data stores at the bottom, we have the one data store, and we have to do things differently. So primarily we use entities, and those entities are related, right? Go back to the slide. Each of these lines is basically an RDF triple that says this is related to this in this way. So the relationships are through triples, and then we project out the SQL and RDF lenses. We call that template-driven extraction, or TDE, but we're often call them data lenses. So here's the overall flow. We take data in, we keep it as is, we map it to a canonical or at least semi-canonical format, and then the data lens automatically and transactionally projects RDF and SQL data. In this example, we see the graph API, and this is done in the example application today. There's an API built on top of the data hub or installed into the data hub that accesses graph data, and it goes to the RDF data lens. And that goes to the middle tier on the front end, and you see that graph, or the nodes and edges. So that's using a data lens. So here's the same data model, but drawn conceptually in PowerPoint to make it a little easier to deal with. Here are the triples, okay? These are the ways that things are related. An author authored a publication. A gene was referred to by a publication. A drug targets a protein. That's a pharmaceutical thing. Drugs tend to bind onto a certain protein in the body. So we say it targets the protein. And a drug has an active ingredient. Move those up top. These are the triples. Now, we've also, in the example app, we added 2 other triples called preferred name and entity type. Those are very useful in order to drive the graph functionality. And I'll talk about that in the cappuccino model. So this is not in our documentation. This is just how I'm describing it. The way I like to think about this is that the entities are analogous to the coffee, or metaphorically the coffee. That's the bulk of the data. That's what you're really there for, to model things in a document-oriented way with entities. However, there's a layer on top that's lifted up and extracted out of those entities, which are the triples. And those triples provide an area where you can query using pure semantic technology, in particular, mostly SPARQL. SPARQL is the W3C standard to query RDF, so if you're into that world, that's very familiar and comfortable. And by projecting some of the information up here, you can do things purely in SPARQL, and we do that. The graph that you saw, where everything was moving, linked in nodes and edges, that graph is purely powered by MarkLogic SPARQL. And let's see if we have an illustration of that. Whereas the detail pages, I didn't go into a detail page, but here's a sample decode page for for a drug called hydrocodone bitartrate and ibuprofen, a mixture, chemical formula, and so on, active ingredients, description, usage, all that stuff. This comes from the entity. So it's a single disk seek at the end of the day. It's a simple call, go get me this record so I can show it on the screen. Very easy, very efficient, great thing. However, when I want to do the graph, I need to wire some things together because the graphs are fundamentally about hopping links. So these links between the drug and the protein, remember I said a drug targets a protein? That's based on the targets relationship that's stored in triples. And then I know what color, to render these on the graph, what color and icon based on the entity type. Proteins are red circles, drugs are yellow pills. And then there's also preferred name data up here in triple land, up here in the cappuccino foam, right? The preferred name allows me to put a name below the dot. So this data up top is fully capable. It has everything I need to completely render the graph. And the data down below is for other things like searching and analysis and reporting and detail screens. I want to also introduce the concept of a concept. This is something we use in the sample application. And it's not in our documentation. This is just something that I'm using to describe it. What we have here, we have blue dots. Liraglutide. That is a chemical in this drug. Also insulin degludec. That's also an ingredient in this drug. So the drug has links to the ingredients. In graph land, in the RDF triples, the blue dots have all of the data that a full entity would have. They have a preferred name, so we can label it. They have a type, so we can figure out the color and icon. And they have relationships, such as the has ingredient relationship. However, the syringe, which is a clinical trial, the yellow dot, which is a drug, they have entities behind them. So entities exist. The blue dots are simply bits of data that we have pulled out of the drug. They exist as first-class citizens in the graph, but they do not exist at all in the entities. We call those a concept. And that's just a useful thing to do to keep our minds clear about where these things live and how we treat them. And here's the actual example, not actual example triples. These are hand-edited to be similar, but we have a drug which has the entity type drug. What does the entity type do? Let's just put it as a blue dot. We have an ingredient, a yellow, drugs are yellow. Ingredient, liraglutide, which has a preferred name, liraglutide, so that allows us to put the label with all caps on it and so on. And these triples drive the graph. Okay, now the way we store the triples, very important. We put them on the documents or we extract them from the documents. So the triples are tied to documents in our example app. MarkLogic has another feature called managed triples. We just throw the triples in and MarkLogic will put them into buckets of triple storage documents for you, and you won't even have to know about how they're stored. But we prefer unmanaged triples, and the reason is it allows you to use a combination of document query and triple query. That's why MarkLogic is great for triples. We tend to end up being 10 times faster than other triple stores, not because of our triple algorithms, but because we can allow people to use the document queries to guide and combine with the triples in many cases. So here we have three authors. They're a little different, Sheng S. Mao, Jing Mao, and X Mao. They're the same person, but there's a lot of transliteration and naming issues with the first initial and so on. And they authored three different publications, Pub 1, Pub 2, Pub 3. And you can use SPARQL to find things. You know, what are the publications of this author? And more realistically for graphs, show me all of the employers of all of the co-authors of all of the publications that this author has authored, right? You can link many hops through the graph very easily. So you can do these two SPARQL queries. Problem starts to arise when we have two sets of authors. We have mastered authors, and they have status mastered. Then we have these three, and perhaps after the mastering process, the smart mastering process, they've been marked as archived, and we don't actually want to query them for our normal queries. Sometimes you want to query them for historic reasons, but not typically. So to query just these authors, there's a couple ways to go. One is to clutter up the graph, where we add more triples to things, and we do a more complicated SPARQL query. I don't like complicated SPARQL from a human standpoint. I don't like to read it and decipher it, and I don't like it from a computational standpoint. Every little clause in a SPARQL query is an in-memory join. and joins have cost. I don't like cost because of the performance impact. So personally, I go this way where I put the triples and the documents together, and I use this function, ml-gradle, which combines a document portion and a SPARQL portion. So here in dark green, we have some SPARQL, but we've associated it now with this light purple property value query where the status property has the value of mastered. And what that's going to do is it's going to use the document and whether or not it has the status mastered or not to restrict the universe of triples to look at. So this mastered document has 3 triples. We're only going to look at these 3 triples and all the triples on the other mastered authors. All of these with status archived, they're not even going to be part of the equation. And that makes things much more efficient. The amount of data being pulled from the indexes and joined and dealt with is smaller. So it's an efficiency approach. And to summarize that, use a structured search to constrain the RDF universe. Property value query is a structured search. It avoids modeling things in RDF, it avoids a lot of joins, but it requires that you put your entities and triples on the document, or you use TDE to pull them out of the document. TDE does this for you. When you project things out of a document, those triples remain connected to the document in the indexes. Okay, now I'm going to talk about the envelope pattern. The title here is Decoupling Internal and External Data. I feel a little like Marco Rubio, but I have a MarkLogic mug, so that's okay. So here's this line between the header section of a document, and I just want to acknowledge we're now showing JSON on the screen. So if you're not interested in this low level, just hit the fast forward button. This is a virtual MarkLogic world. Here we have external data, which is the instance. This is the real drug. This is what we show on the screen. This is what we serve up through data APIs and data services. Okay, and architecturally, I really want to emphasize this. My rule when I lead a project is you can couple the instance data to your services. Do not couple, meaning do not send this directly out from the headers area, because that is internal data. So these arrows down here are things like the drug name and the text, which gets shown on the screen for external. For internal, I want my facet values to work a certain way. Maybe if I decide I want all of my generic medicine names to be capitalized, I would put the capitalization up in the header, because that's not something that I want to muck around with in the main document. I just want to put it in the facet a certain way. So this generic medicine name is driving facets. It's in a section called Common Facets. And again, you can download the Research Hub from the MarkLogic community GitHub, and you can see how that works. This other section has active substances with the URI. I think I called those drug ingredients. They're the blue dots a little while ago. In the system, they're actually called active substances. That's the substance in a drug that actively makes the drug work. What we do here is we put the URI of the substance right in here. For ontology experts, it's really the IRI, okay, because that's the phrasing in the ontology world. This is really how you want to make that linkage, and it's being pre-computed here in the headers, and that's a pattern. You want to do the hard stuff by putting it into the headers so it's all staged, and then, as I'll say in a minute, you use the TDEs to pull it out and project it into triples. TDEs are templates that extract. So decoupling, don't serve up the internal header data, and use the headers for TDE prep work. If you have something hard to do, like figure out exactly what the URI is, maybe even have to search for the document and find its URI, do that when you're building the headers. And that's in a step in a flow versus in the TDE. So here's a simple TDE. The reason the TDE is simple is the hard work has been done by putting the data in the headers using the mappings. So I don't mean to give a tutorial on TDEs, but here is headers active substances is what we're going to look at, right? Headers active substances. So we're going to look in this array of one item. And then in each of those, we're going to define a variable called active ingredient IRI, which is an IRI version of a URI. So that's a little variable that's set. Then we create the triple. This drug RI, has a active ingredient link to the active ingredient IRI. And that's it. This is a pretty simple TDE. People get used to this. Another thing that we have in the headers area are facets. Okay, we call them constraints in the search options configuration. If you look in MarkLogic documentation for the function search, I put a colon there, which is the old xquery format. I probably should have used a dot. There's a configuration called options, and these are the search options, and they define what the constraints and facets can be. Just like TDE, we want a nice simple thing. Active substance names is what we're going to facet on, generic medicine names and drug names. So the drug name is in the instance. That's in the main data, no problem. But these other two, we had to put those up in the headers in a certain way in order to make the facets nice and simple. And this is great because if you want a new facet, you just add a new constraint here, boom, and you can use any data you want to drive more facets on the left-hand side. Okay, so our architecture is flows and steps. Probably, I just say these are flows in the quick start GUI, and these are the steps, 2 steps inside of one flow. So this is what we're talking about. But what I'd like to point out is that we have some quasi-types. That's not a real word, but I just made that up. We can think about having one type of data, which is raw data. That's the data where the values and the headers are really the same as the source system. Then we apply usually a mapping step, and we turn it into more of a canonical piece of data. And then often, not always, we master it. So if it's a kind of data where duplicates tend to come in, we'll run mastering on it to make it into one consolidated record. Both of these are basically the same canonical model. However, there is a difference. The master data tends to have arrays in certain areas. That's configuration based. You can say, in fact, one thing I recommend most people is if you're mastering people, and often one of the things that get mastered are people, keep all of the last names, but just pick one first name. And that allows the last name to become an array. The reason is people change their last name more often. A lot of times people get married and change their last name or other reasons. People's first name, they tend to have a few nicknames and one real first name that you want to select. So keep one first name, many last names. What that does, however, is it makes the model slightly different where you have an array in the master data. For both these entities and the master data entities, the TDEs will transactionally and automatically, the TDEs that you've configured, templates, they will project the data into rows and triples. And then finally, you deliver the data with data services. So here is our example application and some of the real data formats that we deal with. So here's publications. We ingest them and map them and turn them into a standard publication. We have PubMed, and we also have some things in JSON from the coronavirus data sets. The publications also have authors in them. So we actually share the ingest with the main publications, but then we map those to the author format. Authors tend to vary a lot and have a lot of duplication, as we showed with the earlier example, the first initial and so on. So we do master that. And then we do some prep for delivery. This is a particular thing to this example. We want to know frequent co-authors. So if people write papers together more than, say, 60% of the time, they're very close colleagues, and we want to represent that as a special triple on the graph. Now, after we master things, we've combined and deduplicated, all of those metrics have been thrown off, and we have to run a new step that runs through there and does some very lightweight measuring, some statistics, what percentage of the time do they author together. So we call that triple fix up, something like that. And that's a custom step with a little bit of code. And all these have extension points. So most people, and we think about what we call persona a lot, the business analysts and normal users of the system will just wire these steps together, decide when they get run and how the mappings happen. But sometimes you need something special. And in those cases, you would call out, not call out, you would have somebody do some development, have somebody write a little bit of code, maybe a custom function to do something like compute the the co-authorship percentages. Or maybe we have some ontology data. We have to look things up in a very specialized way. Somebody would write a little bit of SPARQL lookup. And these extension points get written, and then they show up in the screens. Okay, so here's the flow that I already showed briefly. Here are the flows for the example application. We have some COVID publications, drugs, genes, proteins, normal publications from PubMed and Medline, studies, which are really clinical trials. Usually, there's 2 steps. So if you want to get studies in the system, you load them as is, and you run a mapping step, which is configured by a mapping screen, and you turn them into the right kind of data. And that's it. Now the data is ready to use. But here are the author relationships. So author matching and author merging that's sort of normal for mastering. First, we do matching to figure out what has to match, and then for performance reasons, we do the merging in bulk. We merge things together into the canonical authors. And then here's that step, rewrite headers triples. That's the one that goes into the headers and looks at the co-authorship triples and recomputes those percentages to make sure that we know who's a real frequent author. All right, now I'm going to go into a little bit of a grab bag of specific interesting techniques that we have found useful on this example project. Again, you can go download the project and see how this is really done. And these are just some pointers. So one thing is to find links in MarkLogic using reverse queries. I just want to emphasize, MarkLogic is not a natural language processing system. So if you really want to do sophisticated natural language processing, you want to use other tools. You can run those algorithms in MarkLogic if you want, if they're compatible with the Onyx interface, because we will run anything that conforms to Onyx. That's built into MarkLogic. But if you have a big natural language processing, Stanford NLP or something that you want to run it as part of your ingest pipeline. That said, many times you just want to find linkages and relevance, and what we do is we use reverse queries. Reverse queries in MarkLogic are very powerful. That's an ability to, as a new document, like a publication or something comes in, you could run thousands and thousands of checks against certain criteria in parallel, and they get run immediately without a lot of overhead. So it's sort of like a data filter. So sometimes there are structured links in the data, so let's put that aside, where you get a gene record and it says, I'm synthesized by this protein, and you don't have to detect anything. So that's great. But when there's textual mentions, we add reverse queries and run that during ingest. A trick, really the one that I want to point out, is what we then do in the example app, we turn right around and we query that one document. We constrain the query to be that explicit URI of that document, and we do a search for that same text, even though we know it's there, so that we can check this CTS confidence on the match. And if the confidence is too low, then it may have been something that was just mentioned, in one line of the bibliography, and it's not really relevant to the article, and we don't include it. So this gives us an ability to bring our relevance algorithms into the link detection, which is pretty powerful. Another kind of relationship is to use ontology relationships. So for this data, there's an ontology called RxNorm. When the drugs come in, we do a SPARQL query against RxNorm to find the ingredients of the drug. An ontology is really a small database, so you can look things up in it in that way. Here's an example. So in the gene record, there's this query, which is this is our standard serialization of a query. MarkLogic knows how to identify this. There's a query, which is a word query for these 2 words. These are the alternate names for the drug, Renice, and there's a couple options there. So this is the scanner that allows this gene record to effectively be watching for any publication about it. And if there's a library called entity extraction in the example that you can download and use, and it produces a certain structure. And just for reference, because we're putting all of the links into a standard structure, that then lets us use a template-driven extraction configuration that also has a standard structure. So this TDE structure works with that entity extraction library no matter how you use it. And then here is a different relevance check where, this is a little too complicated to go into, but we check the drugs to make sure that they're really relevant by doing some more word queries. What I want to point out, though, is that this is the mapping screen for drugs. So here is an incoming raw record from the US FDA. And then here's what we're mapping it to, and here are the mapping expressions. So the drugs, we don't have a way to do this text business out of the box in MarkLogic. So we had to go to the mapper, whoever's doing the screen, has to go to the developer and say, hey, I need a special function. And I'm going to call that. So we talk about this in terms of persona. This person might be the mapper, and she's here building all these mappings. When something really strange has to be done, or not strange, but outside of the standard functions, she'll talk to someone else and say, please build me this function. And once that's built, all of the mappers can use it in their configuration screens. Okay, so talking a little bit now about another tip or trick, which is graph recommendations. If you remember when I demonstrated the system, I hit a button and I got these yellow circles that are things you want to read up on because they're related to many of the items that you have in context. And one of the things I want to point out about this is when you do artificial intelligence or machine learning or anything of that kind of sophisticated nature inside MarkLogic, it's usually compelling because there's a real-time aspect. I wanted to know what was relevant to what I had put on the screen at that moment. I didn't want to analyze the entire corpus and extract a vector. I wanted to know what was meaningful to me right there, right then. So for that kind of a thing, you can't do it in the pipeline before it comes to MarkLogic. You have to do it interactively. And that's why we have these ONNX libraries and AI machine learning in the product. So we run ONNX models. We don't build them. I would not, you could figure something out, but I wouldn't recommend building them in MarkLogic. Build them in whatever environment your machine learning experts like. But then once it's done and it's compliant to ONNX, you can put it right into MarkLogic and run it in real time. Real time is a differentiator, but it's a good place to run your models. And you could do your enrichment inside of MarkLogic as well, right? During your enrichment pipeline, you could even expose your enrichment as one of those custom functions in the mapping screens and just put the enriched data in as described in the mappings, the model-to-model mappings. One more architectural trick that I want to show, I think this is a very nice one. Because we're moving to JavaScript over the past many years, and almost, I don't know about almost all, a lot of what we do now is JavaScript. More so than other languages, it has a good class extension capability, especially in ECMA 6 and beyond, the modern JavaScript variants. So it's nice to consolidate a lot of your functions related to a certain entity into a class, and that makes your code much more regular. So here we have a few functions. Get predicates. This is a class drug. So this encapsulates some of the configuration and special processing around a drug. We could put these out in config files too, by the way, but it's not a big deal to have get predicates return an array of 3 predicates that make the graph work. 5 predicates that make the graph work. So we have the predicates there. We also have this set of collections. So remember I said that because the triples are on documents, you can constrain things and get a minimal set of data to drive your universe of triples. This is what does that. These are the places to look for triples that are relevant to drugs. Publications, proteins, and studies all reference drugs, so that's where you want to look for the drug triples, for the drug relationship triples. And then finally, the boost query. This is for adjusting the relevance as you add things to workspaces. So the more you interact with a drug, you particularly put it in the workspaces, it becomes a boost query to inform the relevance of the entire system. And rather than scatter that through the code somewhere, we put that right on the drug. It also makes it more portable. You can now take this drug class and use it in another context, perhaps. All right, wrapping up, getting to the far right of the architecture diagrams is data services and delivery and data layering, or actually architectural system layering. Services, layers, APIs, all the same, really. The example app that we've been talking about is a 3-tier app. I don't know if I'd mentioned that or not. There's the web app, and we saw it. It has all these buttons and search bars and so on. It's a single-page web app written in with the React framework in JavaScript. That sends REST services to a middle tier, Node.js middle tier, very thin. It just handles some definition of some routes and authorization. But almost all of the real REST functions are passed through fairly directly to Data Hub service. Data Hub service, you've heard in many other talks, is the cloud offering where we give a data hub and a framework for that. And what Data Hub service is actually providing, when you provision one, you hit a few buttons and boom, you have a Data Hub service and you have these endpoints, these IP addresses in the cloud to hit. Those are actually AWS Elastic Load Balancers. What happens behind those is automated. So there may be many nodes or a few nodes, and they can grow and shrink and so on. But you're basically talking to a load balancer that just does the job. And through initial configuration, that DHS is then reaching out to LDAP to figure out who's allowed to log in. Okay, so the example is 3-tier. And through that Elastic Load Balancer, there's a bunch of data services that are provided. And I think I have them listed here. Yes. So here are the data services. There's actually a few more, but they didn't fit on the slide. Here are the main data services that are exposed. There is a graph service, so that returning of all the nodes and edges to make the graph work, and all the interactive stuff is through the graph service. The search service, where you type keywords and facet selections and you get your results back, that's another service. Those are both read-only. Workspaces is a CRUD service, right? Create, read, update, delete. You can add, remove, delete things in and out of workspaces. That's a different service. And then we hit the AI recommendation button. That's a different service. So these are fairly high-level, well-formed services that you can call directly on the Data Hub. We pass them through a middle tier, but the middle tier doesn't really do much. One interesting thing to note, most of these search and workspace are accessing the mapped and mastered data, so the documents. But the graph and recommendation endpoints are accessing the data that's been projected into RDF using template-driven extraction. So we have these, it's the cappuccino model, right? Some things are accessing the foam on the top of the cappuccino, and other services are accessing things that are in the bulk coffee area, which is the documents, and you can absolutely combine them. In fact, our Optic API is specifically designed to allow you to combine SQL, RDF SPARQL, text search, and structured query all in one query with one optimizer and really make it work. And then the web application is the middle tier. So I think I mentioned what these are. There's the graph endpoint, which runs on get. It returns a format that's been transformed a bit to be a closer match to the rendering libraries in web tiers. Graph visualization libraries want a certain road edge format typically. /entity, this just gets stuff. I need this drug, I need this publication, I need this protein. A search, and then the workspace. A word on DHS. We use DHS in the example app, and it just makes things go faster. There's a lot of things that we were able to do by logging into the DHS console and saying, I need a certain size cluster, or it's not, I know it's a cluster, it's really just I need a certain size instance, and below that is a MarkLogic cluster. And how that cluster got set up, how many nodes, and how the elasticity is configured, and what kind of disk, and what kind of AWS X2 large mumble schmumble, all that stuff is abstracted away. I just know that it's going to work. It also divides up endpoints into different purposes. We almost exclusively use the ingest during data loading and the data services to run the app. We don't do very much with the analytical endpoint. Mapping is actually a mistake. That should be the analytical endpoint. There's not a specific endpoint for mapping. And you'll find DHS familiar. The way we developed the sample app is we developed it on laptops with a few hundred records of various kinds. And then only when it was time to really make sure things were working and it felt right, then we provisioned it into DHS, and we did development on DHS. You're going to be very comfortable in DHS if you know MarkLogic's other technologies. There are differences, but you're going to be comfortable. A couple things to become aware of as you are on your DHS journey, if you will, is to access your logs via HTTP log endpoints. You can regex through the logs and download the logs that way. And to do your debugging not through the QConsole app, but using the VS Code editor. There's a plugin that allows you to do dynamic interaction using that. Okay, well that's pretty much everything. I don't know how to summarize this. This is a little bit of a grab bag today, but I hope that the DHS vision kind of comes across. Integrate the data, track it, govern it, enrich it, and then one thing you can do with it is have a web app to do discovery, and then the semantics is key to that, and there's even AI built in. So that all comes together, and the way it comes together is a little different because so much of it is combined in the server. Most architectures to do this would be talking about how to combine 9 different products in some cloud vendor, or how to, wire things up. A lot of it is wired up inside of MarkLogic server so that you don't have to. So that the nature of architecture actually shifts when you have a very powerful multi-model database and a very powerful data integration platform. I hope that comes across. The goal at the end of the day is curated data. We showed it in a web app, but that curated data is gold. Send it to your data warehouse, export it to your machine learning group, send it to your downstream systems, do your reporting on it. Put your security, your validation, your mapping rules, and so on and so forth into the data hub to the extent possible, and then that data will serve many purposes. And the multi-model nature changes the architectural patterns, as I mentioned. So go forth and enjoy MarkLogic and learn new things. The example application is here in the MarkLogic community section of GitHub. MarkLogic has a product section. These are for open source community tools. It's called MarkLogic Research Hub Framework. There's a long guide to tell you step by step how to build an app like the one you saw. And there's some videos that say this little bit of the screen maps to this little bit of the system. So if you dig through that stuff, you can really trace the interesting techniques that you found relevant in this talk to specific bits of code, or you could even build your own discovery framework. Thank you very much.